doesn't have a magnetic field. So Venus is just this big rock with this atmosphere and the ionosphere sitting in space, and the supersonic solar wind with the interplanetary magnetic field whacks into Venus, and it can't penetrate through the ionosphere. So the interplanetary field lines just sort of pile up ahead of Venus, like cars on a freeway. This solar wind whacking into it essentially sort of strips off the atmosphere, and it literally forms this long tail, like a comet, but stretching out into space. Pioneer Venus Orbiter was the first spacecraft to really thoroughly explore that night side region where the atmosphere is all escaping away, and it discovered this really mysterious phenomena which has yet to really be explained. Imagine that we're flying from pole to pole on the night side, so we're feeling the plasma around us, and then suddenly the ionosphere disappears, and then it sort of comes back. And this is what an ionospheric hole is. It's like a chasm in the sky, a big hole where the ionosphere is just absent. So Pioneer Venus Orbiter basically measured inside these things, and we saw that there is very little plasma, and there's all this magnetic field. And from that, they sort of suggested that this is essentially a magnetic structure that's sitting in the night side. I wanted to see if I could go looking for these things with Venus Express. What we saw is essentially this really exciting, strong Drake magnetic field lines that we expected, and really boring plasma signatures. It shows us that this is a magnetic structure, right? This is a tube of interplanetary magnetic field that, well, PVO saw it coming out of the ground, and now we've seen it way out in the tail. So these things really continue out to much higher altitudes than we previously have found them at. And the other thing that's important is, well, Pioneer Venus Orbiter only saw them during solar maximum, when the sun was really disturbed and really blowy and stormy. But we've now been seeing them all throughout the solar cycle. There's sort of two explanations for what might be causing this. One possibility is that so these field lines, they come in from space and they get sort of stuck in the ionosphere. The ionosphere sort of flows from the day side to the night side, and as it goes around, it sort of meets this plasma that's in the tail, and there's sort of a pile-up between the two. So that's one idea. And the other idea is that on the day side, the field lines come in and they actually sink through the ionosphere, go through the rocky mantle, and then get hung up on this big metallic core. These field lines essentially end up draping around the core and stick out the rock at the back. One of the main differences between Venus and the Earth is simply that Venus doesn't have a magnetic field. So the way it interacts with the star is completely different. If you want to understand how did Venus get that way, why does Venus not have any ocean, you need to understand the interaction between the star and the planet.